Hello, good morning, evening, afternoon, wherever you are in the world. Hope everyone's having a pleasant weekend. Wait a few minutes, people sort of roll in. So yeah, this week, as I say, is tradition. I've only done it once before. After a video, it's kind of nice to go through some of it live on stream. I'm sure people have some questions, and kind of the process of producing a video kind of necessitates cutting certain bits out and smoothing over certain bits. So it's kind of nice to take a little bit more time and kind of go through the mechanics a little bit slower. So yeah, that's what we'll be doing today. So this will be, if anyone's not seen it, the last video was looking at bypassing or attempting to bypass some of the Sims 2 DRM and some of the interesting kind of, I don't know, anti-debugging techniques, etc. I feel quite happy kind of going quite in depth to a lot of this because you can't really, as far as I'm aware, you can't really buy Sims 2 anymore, or I think it's either free from EA or so I don't feel like there's anything too bad about doing this, if that makes sense. So yeah, we'll do that in a second. How long am I streaming? I normally stream for an hour and a half to 2 hours. It kind of depends, what I want to get through and what it's like. Yes, x86 today. Sounds like someone's been looking at ARM recently. I personally prefer ARM. I think x86 is a bit of a hot mess, but it is kind of what we've got for a lot of games. So here we are. Yeah, I guess it would be generic secured. Well, what I want to start off with looking at the beginning is the key gen, which I think is Sim specific. So I don't really mind. Well, I mean, I don't actually know, but I feel like maybe that is more specific to the game. Yeah, I guess is more of a generic secured workaround. It's it's an old tech now. It's for old games. I don't really feel like there's nothing. I feel there's no reason why we shouldn't be looking at these kind of things. I think it's important to kind of preserve these old games and make sure that they're still playable. If you own a copy of the disc, which I now do, I think it's important that you can still play these things. During a recent RE exercise, I found Ghidra really let me down compared to Binary Ninja. Do you have any opinions on Binary Ninja? I know it's not free, but then again, it's not very expensive. So Binary Ninja is an interesting one because my experience with that is, I think when it was first released, I don't think it had a decompiler when I first looked at it. I think it only had a disassembler and then like a graph-based control flow viewer thing. I have not looked at it I've not looked at it at all recently, so I'm maybe I'll get a trial and give it a go. It's one of those things where I'm always interested in improving my tooling and making things better and making my life easier. But at the same time, a lot of this stuff is quite complex, and when you kind of get into a flow with a set of tooling, it's kind of nice to stick with that. So there's kind of a bit of a push and pull there. But yeah, my opinion of Binary Ninja is I don't really have one because I've not really used it since I think it first came out. So yeah, I mean Ghidra is. I mean, the thing with Ghidra is like the price is right. You can't really argue with that. I used to use way back in the day IDA, like the full-blooded IDA Magic F5 Hexphrase, whatever they call it. With all the plugins, but it's quite expensive. But anyway, yeah, I've got the Sims 2 code keygen stuff open. Let me just if I actually run this, so we can see what we're talking about today. It's pretty easy if I run it in the debugger. I think my face might be over some of the register values, so we might have to move that later. Although I think we can kind of see them all. If anything's not clear, I think I've got half decent font sizes for kind of readability. But just shout out if it doesn't make any sense. If you can't read it. Yeah, I mean, you got to find what works for you, right? I should probably take some time to look through it, but at the same time, I've just not found the time to kind of look through any of those other toolings. But, you find what works for you. I think it was like a low cost. I think it was like a one-off small cost for a perpetual license. I think last time I looked at it, maybe that's changed. Anyway, so if I run the keygen, I get this, and then I have to enter a key, and then if I don't enter the right key, obviously the game will not install. So this is kind of, this executable is I'm just running in isolation. It's not part of the installer. The installer launches this and then expects this to return some sort of true or false value of whether you successfully managed to provide a correct key. So as I sort of said in the video, there's a couple of ways you can get around this. You could just create your own binary which returns the right, runes, whatever it needs to be, true or false or some sort of string. Or you could patch the installer to, just assume that this always returned the correct value, but I think it was more fun to kind of dive a bit deeper into this. Do I have a GitHub for these projects? I have a GitHub for some projects, but not all of them make them to GitHub. It kind of really depends on whether it's code I want to share with the world. A lot of it is kind of lashed together, not great, and I don't think it's particularly useful to anyone without the wider context. But some stuff is like the hacking framework that we built live stream, which we've kind of quote unquote finished, or sort of wrapped up like a month or so ago. That's all on there. That's got some good bits in it. And I want to start a new long-running stream series, and I'm hoping I can start that maybe next weekend. That will have. That'll be something that I will kind of work on over several streams together. It'll be more coding based, but I kind of want to try and ramp up the streams a little bit. I'd like to try doing it twice a week, just because I'm just a few streams short of getting the Twitch affiliate program, so I kind of at least like to tick that off, got that achievement as it were. So we'll see what happens, but yeah, we'll kind of go through this today, see where we get to. If we don't get through as much as we want, maybe we'll do it next week as well. But that's kind of my plan at the moment. So if I click next on this, it's obviously it's not Diablo 2 where you've got a 1 in 10 chance of just guessing the right code. As here says, I've got an invalid code. So the idea now is I want to kind of go through the process that I did to pull out a key gen and then be able to generate our own keys. So it gives a chance for people to ask questions and kind of see the process in a little bit more detail. Why is making Ghidra look good harder than making a keygen? Yeah, Ghidra, it's not the prettiest software in the world, but I find that a lot of these kind of low-level tools are designed for function over form. They don't tend to, look that great. Is there no existing keygens, or is this a question of principle? This is 100% a question of principle. You could absolutely Google for a keygen or Google for an existing key. I just kind of wanted to solve it myself. Yes, this is a stream, not a premiere. I did the premiere. I tried premiering for the first time. The Sims 2 video was the first premiere I tried. Seemed to go quite well. I think we had 200 people show up. I'll probably do it again in the future. It's kind of nice chatting with everyone. But I did do that in lieu of last week's live stream, because I do try and stream at least once a week. Okay, so what we saw there, when I'm sort of first looking at this little bugger here looks a lot like a Win32 message box. So that's kind of the initial thread to pull on, right? I'm going to set a breakpoint on the Windows function that creates a message box, and then we're going to, that will give us an in, because at least will stop us at the point where it has evaluated that key and the programmer has said no, and it's shown a message box. So that we can kind of go from the back, sort of from the bottom up. The alternative is to go from the top down, and you basically just start at the entry point in Ghidra and then just start going through all the code and trying to figure out how it works. I think this is infinitely more difficult, because for anything other than a trivial program, if the code branches, then you've got to kind of investigate both sides of it, and then if that branches, you have to investigate both sides of it, and then you kind of got an exponential sort of pathways of sprawling code that you need to try and figure out. So yeah, let's go back to our program. Okay, and then what we'll do is we'll go to so I'm using x64 debug, which is a Win32 debugger, sort of GUI based debugger. It's actually the x32-bit variant because it's a 32-bit program debugging. And if you go to symbols, this shows you all the symbols of all the modules that have been loaded. So you can see here, sort these by name. These are all the modules that this executable has loaded just to be able to do the thing it's doing, and it includes the module itself. And these are then all the symbols. So the game itself doesn't really expose anything other than an entry point, which is fine. It's an executable. It's not a library. It's unlikely to export anything. and then standing desk or pitching cruise ship. Maybe both. It's impossible to say. I have just upgraded my desk and my working environment to. I'm trying out a standing desk. Also, it means I've rewired and moved the mic, so no one has complained yet. But I assume the audio is coming through quite clear. Also, I tweaked some of the stream settings because last time I streamed, YouTube was having a funny 5 minutes and kept popping up warnings saying there was like latency issues and stuff. So I've kind of tweaked the settings a bit. So hopefully that's. Provides a slightly better viewing experience for everyone. Yes, starting at entry point is a bad idea for programs, I agree. Somewhere in here is user32, which is basically all Windows libraries link against and bring in. This gives you a bunch of functions, and then so there's there should be in here message box A. There is an XA and XW. I've never seen anyone actually call those, but that doesn't mean they don't exist and they aren't used. But I don't think I've ever seen anyone use them. And then you can match this up to the doc, right? So here is the Win32 docs for message box A. Nope, I will not be going to Microsoft Ignite. Go away. So, displays a modal dialog box that contains the system icon, set buttons, blah, 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 etc., etc. It's got some arguments. So this is what we're going to want to break on. So if I, straight from here, I can just press F2 and it'll set a breakpoint on it straight away. Or I could double click to get the code and then I could either toggle the breakpoint here or, again, press F2. I'll kind of go through a bit more of the key bindings and mechanics of the debugger because, again, in a video, I kind of sort of like click, 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 done, 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 and then if anyone's actually wanting to learn any of this, it might leave you kind of in the dust a little bit because, again, it's kind of the nature of making an entertaining YouTube video. How long have I been reverse engineering this hell? This, I worked out, I think I spent about 100 hours on this video, just on the technical side of the video. That doesn't include the scripting, the filming, the editing, the thumbnails, and all that sort of stuff. So I think about 100 hours of content, roughly. I don't keep track, but kind of doing the maths in my head of how many late nights I had. I think that's about it. Have I ever looked at RSims 2? From what I heard, they've fully reversed it, so Playable and have a guide. Oh, so this is a really good point. This is an excellent question from AC. Is that did I look at what was already done? And when I do these videos, I very deliberately don't look at any prior art because a lot of these problems are already solved. I wouldn't say I was doing anything brand new or groundbreaking. I'm looking at games that are really old and were reverse engineered and probably hacked and patched like 2 days after they were released, all the way back when they were released. So for me, the puzzle is just seeing what I can figure out myself, and that kind of involves me not looking at any prior art. It is tempting. It's really tempting when I know it's already been solved, like safe disk or whatever it is has been cracked for years. So that's kind of my mentality of it, because the videos, for me, I think it's more about the journey than the destination. I like to take people on the thought process and the journey that I went on to get to wherever I end up. And, I don't always get maybe the most, the happiest or most satisfying ending. And, it's just the way it is. But I do think at least the videos are hopefully entertaining. Yeah, it's the challenge, not the result. It's a puzzle to solve, or at least try and solve, or at least see how much of it I can solve myself. Yeah, I played Skyrim when it first came out. That's great. I've not played Skyrim in many years. In fact, I've not played any game in many years because now I do this. So anyway, if we let's bring our executable back up, and if we hit next, then hopefully the beautiful user interface has indicated what has happened, and this has gone green, which means we are now paused here. So we can see the arguments to the function on the stack. This is the 32-bit process, which means arguments are pushed on the stack, right to left. So the top of the stack is the first argument. So that would be the hoind. Let me embiggen this a bit. The hoind, the handle to the window, which is some opaque integer handle to some Win32 internal construct for representing window, and then you've got the text and the caption, so you have entered a blah 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 and Sims 2, and then the type. So that's what we can see here. I've lost it. Oh no. Okay. Excuse me. Yes, I also take it as a personal challenge for self-improvement. I don't do reverse engineering or anything like this. They as a job. So for me, it's kind of keeps my skills up to date and a personal, like a different challenge for myself. Yeah, and I want to make it all available for free because I've had fun doing it, and I hope other people enjoy it. So anyway, so now what we can do is we can click on the call stack, and this shows us the series of functions that have taken to get to where we are. So we can see here that at the top we're in message box A, and then these are the series of the internal functions that were called. They've sprung up somewhere from, like, I don't know, ordinals and call window procs and dialog messages and some internal Windows construct which probably created that initial window, and then the button was clicked, and then that fired off a whole series of events which basically went through all this, and we ended up here. So I don't really care about any of this bottom chuff here. It is that. So what we can do is we can click up and then be like, here we can see the call to message box A. So this was the actual Sims code, or the keygen code that called the message box. So we could set a breakpoint here and start figuring out what we want to do. What I like to do now is actually, so I find this is hard to read, right? I don't think anyone's pretending this is easy to read. Ghidra does make this easier. So if you press Alt Insert, that will copy the address, and then if you go over to Ghidra, press G to bring up the goto, and then paste that in, it'll take you to the call here. So this was that function that called the message box. Now, I hope we can all agree that this is a lot more understandable than this, or at least to me. Maybe not to you, I wouldn't like to say, but for me, I find this a lot easier to read. So what I'll do now is we'll kind of go through this code, try and get an idea of what's going on, and then we'll basically work our way up the call stack until we get to somewhere that is, useful. So yeah, x64 and x86 are very, very different. I won't go into all the differences, but it's not like one just becomes the other. But like, unsurprisingly, I have a 64-bit processor, and I can run 32-bit processors on it. And Windows has a whole load of backwards compatibility stuff, like WoW, Windows on Windows, and WoW 64, and all that sort of stuff. So yeah, you can kind of get that backwards compatibility. Thank you very much for the super chat. No, this is not pre-recorded. This is live right now, right here, right now. Me trying to remember everything I did 2 weeks ago in front of an audience of like nearly 250 people, which is good fun. Okay, so I'm just looking at this code, and the thing with reverse engineering, it's not necessarily about what is important, it's also knowing what is not important, so you don't have to worry too much about it. So I can see here that this calls the message box A function with the window handle, and then these parameters, which are also these parameters up here. So I know that this function being called is just passing these to Windows message box A. I don't actually really care about what any of this does. Because just glancing at it, it's an if-else, there's no early exits, there's no extra weird function calls. No, thank you again for the super chat. No, I'm not nervous, I've been doing this for a few times now. I get, there's always that sudden, sharp intake of breath, at 7:59, 1 minute before I go live, when I think, right, I have to be entertaining and engaging for 2 hours. But once it starts and you guys roll in and start chatting to me, it's all pretty easy. Easier than doing all this anyway. I watched a video recently, and they were using a tool called Pharos to do C++ code analysis and loading the results into Ghidra to augment the analysis. Is this common? I am not familiar with that tool, so I couldn't really say, but I will, if I remember, I will try and check it out. Because I'm always interested in learning new tools. Yes, so this code maybe is C++ because it's got this pointer here. Ghidra is not perfect. It will do its best to try and figure it out. Although it does have the this call calling convention, which is Microsoft used for optimizing C++ code, because you could pass in the this pointer, I think, is ECX, if I remember off the top of my head, which is just one less kind of thing you have to push to the stack. I really don't think EA care about what I'm doing. I don't think I'm costing them any sales or money. If anything, I'm getting people interested in playing Sims 2 again. So I'm not too worried. I do think like there is a bit of a, I do toe a bit of a grey area, I think, but I like to think I'm reasonably sensible about what I do and don't show. And I'm not here to support game piracy or to people not to be giving developers money. So, I wouldn't, if you could buy this game now, I wouldn't be showing people how to do a keygen, for example. Yeah, exactly. It's old games. I'm more interested in the preservation of them than the kind of, facilitating piracy. Anyway, so what I was saying is, like, I don't think I care about any of this, because you pass in some arguments and then you pass it to message box A and then you return. So I'm going to posit that this function is effectively just a wrapper around a message box A. If you want to dig into it a little bit more, you can see that it's, checking to see if you've got how it gets the handle to the window. But largely, I don't actually care where the handle to the windows come from. This is not the problem I'm trying to solve. The problem I'm trying to solve is, like, who is calling this and why. So then you can just, like, rename this to something to make it a little bit easier to, like, I don't know, message box A wrapper. Okay, so that means now in Ghidra, wherever this function is referenced, you'll see message box A wrapper rather than fun 416AAB or something that's much harder to kind of like keep in your mind. I can't just sort of remember what's sort of hanging off the end of every single hex address. And it's quite funny because when I look back at my notes for these kind of things, there's normally just a long list of hex addresses, which on reflection I'm like, those were probably important. I probably needed to know what was that address, but I can no longer remember. Yes, I'm from the UK. I don't know if that has any implications to the law, but no one's told me anything yet. Patched your own SimCity 2000 save load bug with my video. Just enough info to piece together the puzzle. Oh, I'm glad it was useful. Thank you very much. That feels like an age ago doing that video now, but it's one of my more popular ones. So I'm glad you enjoyed it, and I'm glad it was useful. Okay, so then we kind of got two approaches here. I can either select this function and do Control-Shift-F, which will then give me all the call sites to this function, and now it's 4 again. So I kind of be like, well, I could click through all these to try and find who's calling this. Or what I'll actually do is, if I just go back to the call stack, I can go one up, because this is exactly who called it. So this call here was the call to that function. So again, I'll insert back to Ghidra, G, paste the address, pop out here. And have I done that right? That doesn't seem. He said confidently, and then it was not what he was expecting. Why is that going to dispatch F? Okay, fine. Can't remember this. The call site seems slightly messed up. Unless I've got to go further up. I'll just keep going up until I find something that looks like what I want. I think this might be message passing chuff. So let's go back. To where we were and let's find all the callers of this. Again, I'm not perfect. I'm not an expert in this. I sometimes get things wrong. So we'll see where we are. Okay, fine. So this function is interesting because here we can see we call our message box wrapper, and then we have this like end dialog, which probably means something is closing or something is ending. We also have another call here, another call here. So we're calling this a bunch of times. What I remember looking at this originally, and what caught my eye was actually this, because this sprintf, this is a C function, which will produce a string based on this format, and then the sort of variable number of arguments at the end. So this is basically saying, can you create a new string, which is a string and a string and a string and a string and a string? And this happens to, I just remember seeing this and thinking, that's the same number of %s's as there are message boxes in the game, in the text input. So we can kind of like verify this. Let's take this address, go back to the debugger, and then in x64 debug you have to press Control G to bring up the follow go-to expression thing, because G puts you into the graph mode. So I believe this is the call to sprintf. Let's check that. So that is A7F, A7F. Right, so let's try again. Let's just continue this. Okay, up here. A, B, 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 C, 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 D, 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 D. When I do these keychain things, when I first started doing them, I used to just put all A's in there, and then it turns out it's actually quite hard to see what's going on if it treats each of these ones separately. So I try and put a different thing in each box, just to learn that lesson the hard way, because it's easy just to mash the A key. Yeah, we're looking at keygen today, just one from a YouTube video I did recently. So click next, and then okay. So we are at the sprintf function. So we can see on the stack is. Check my mug isn't in the way. So the first argument, so this will be the output. If I remember correctly, I'll check the docs in a minute. I think this is the first output as a address of where you want to write it. Let me just check this. Sprintf. A pointer to a character where the resulting string will be stored. Yeah, so this is the output array. So this is the pointer somewhere you're going to point it. This is the format, which means here is %s, 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 and then we can see the rest of the arguments here are all parts of our key. So what we can do is if we right click this and go follow this and dump, this will take you to this address here, which currently has like nothing of any particular use in it. But if I press F8 to take one step over the function, then it's now written out to this our string. So we can see here that this is how it kind of combines all those parts together. How do you learn this stuff? Just write code and take it apart and see how it works under the hood, and then kind of rinse and repeat. Do CTFs. There's plenty of hacking, binary exploitation sites and challenges you can do. It's just a way of kind of figuring out how a computer works and playing around with it. Okay, so that's the sprintf there. Let's get Ghidra back up. So again, kind of just looking through this, we know that we display a message box error if on these two else cases. So if bvar 1, right? So if this value is not 0, then I don't know, we end the dialogue and then we do whatever this is. I don't particularly care. It's doing something with a registry. Maybe it's setting a valid value. Who knows? Don't care. What I do care about is the fact that these message box A wrappers are called in the alternate cases. And as far as I'm aware, if you get it correct, it doesn't pop up a message box. So this implies that this is, it's kind of this kind of logic that you can kind of work through without, it kind of simplifies the amount of code you actually have to pull apart and reverse engineer. I know that the message box is bad, so this is probably good. So what we're thinking now is that this function here is probably doing the checking, and from here, this code kind of is driven based on the return value from that. Yes, maybe we should have some 90s and 2000s chip music playing for when we're cracking this, although I don't know if there's any royalty-free one, and I suspect it'd probably get quite irritating after a while. Did I do the CD crack? I'm looking like we're kind of working way through it at the moment. Why do game devs always name variables badly? I mean, bad is subjective. This is not, no one in no one in their right mind would probably call their variables these. This is just Ghidra's sort of heuristic approximation of the code of the assembly of C code, and it just gives it these auto-generated names. So these aren't real variable names. I think the worst I've ever seen is variable names in Finnish, and there is a whole video on that which you should definitely watch because I think it's personally one of my favorites. But yeah, this is just auto-generated code. So click in here, and then this is just calling through to another function, and then it's doing something else, right? So again, you can see here it's sort of return true, or return some sort of calculated value. So I'm starting to think now that this is probably what we want. So what we'll do is we'll go into here and we'll take the address of this, and then we'll set a breakpoint on here, and then look at like the arguments that are passed in, and then start having to play around with it. So set a breakpoint here. So you just press F2 to set a breakpoint, and then press F9 to continue. So it's now gone over that where we had the previous breakpoint on the sprintf stuff, and we can see here that first argument here is our string, or a pointer to our string. Again, follow this and dump. Here it is. So you're starting to think now more and more likely picking up, pulling on the breadcrumbs that we've got, and looking at the kind of the heuristically all the bits of information we have. This function is probably going to be doing the key check, because we have indeed passed it to the key, and based on the return value of this, we either show an error message or we don't. I appreciate that you wish the functions were as fun as they looked. I appreciate that. Thank you very much. Pwn Adventure 3 Pony Island is an incredible game. I think I played the second or third one. I think that is made by the same people who made Binary Ninja, because they use it as a training course, like training material. Like you can get the Binary Ninja people to come in and teach you Binary Ninja, and they use that game. I'd have to check that, but I do remember playing the Unreal one they did, which was incredible. That was really good fun. It was a multiplayer game. Everyone's in there, and then you could fly. You could hack the game so you could fly, and so you could run super fast or access hidden areas. It was good fun. I remember doing that as a CTF. Anyway, I digress. So again, I try to. Reverse engineering is hard and takes a lot of mental effort. So I try and do stuff practically, I guess. I guess there's kind of two ways you can analyze a problem. You can do static analysis, or you could do dynamic analysis. So static analysis would be just clicking through all this code, trying to figure it all out, and just staring really hard at the assembly and the decompiled code and trying to divine whatever answer you want. Then you've got dynamic analysis where you actually run the program. You give it different inputs. And you kind of need both approaches. But, so we're going to try and do a bit more dynamic analysis on this. So we can see here we've got two function calls right at the beginning here, right? These two function calls here, and we can see those in the assembly here. So if we just F8, just step through the program, instruction by instruction, kind of see what happens. We'll get to here, and we can see we're passing in, I don't know, some address, which is very similar to this address. So they're probably, similar usages. They're probably data that can be written to. In fact, actually, I think it's looking at it, it's a stack address. So here is a point address on the stack. Do you use Discord? Sorry, thank you very much for the super chat. Do I use Discord? I'm doing a project. I need help on something. I need to disable a menu item used by WinH. Would be cool to chat if possible. So this comes up every now and then. I don't feel I have the time at the moment to run. I'd love to run Discord. I just don't really feel I have the time at the moment to dedicate to that, because I'd want it to be, a good experience for everyone. It's not one of those things I want to just be just start and then kind of let languish or forget. I want to be able to dedicate the time to kind of, building a good community through it. So at the moment, AC has kindly set one up, but I've just not kind of made it public yet, because I'm just not at the point where I feel I could put the time in. What I would suggest is if you use the email address on the YouTube contact page, feel free to send me an email, and if I have time, I will try and respond to everyone. And I've given out like the odd bit of advice before to people, or people have suggested ideas for videos, so do feel free to just reach out and contact me. That's just like an open email address. I make absolutely zero promises on responding, but yeah. Do you mind if I post the link? The link to what? The email address? Yeah, sure, it's fine. It's public. It's just on the YouTube page. Like, you can very easily go and find it. It's not a secret. And you know, if all gets too much, I'll just delete it. So I really don't mind people contacting me on that. It's absolutely fine. Again, I provide zero promises on whether I can get back to you or whether I can actually provide anything useful, but do feel free to reach out to me. Oh, someone's mentioned Legend of the Cyber King. I don't know how much. Like, I'm interested to know what your experience of that is. But yeah, that's a phrase I've not. That's a game I've not seen in a while. Anyway, so we can see here that stack address is passed to the first argument, and then the our key, there you go, that's the word I'm looking for, is passed to the second one. Hello JJ. That's I used to work with JJ many years ago, so it's nice that you're here. Okay, so what I'm thinking is this is some sort of stack address, right? So first thing we should do is dump it. So there's different dumps here, so you can kind of keep things you kind of, you know, compartmentalized and see what's going on, and you know, you don't have to kind of, you know, it's useful to be able to see visualize different aspects of memory at the same time, kind of keep the context in your head. So I'm just switch to another dump, and then we can dump this one, and this will just follow in the current dump. So again, it looks like a bunch of chuff here. And then what I'm going to do is I'm just going to step over it to kind of see what this function does. And now I can see here that this is actually written out part of the key. But what it's done, again, like I don't know, smash cut to the answer a little bit, but we'll kind of dig into it. You know, I've got a little bit of guilty knowledge here. This has shuffled those characters around. So it's kind of mutated it, but it's not mixed in anything new. All it's done is move those around. And we'll kind of dig into like how you would figure that out for yourself. And then the same thing here for this next function. So we've got a stack address, so I'll follow that in the dump. And then the input is the output of the previous function. It'd be the same stack address. So follow that in the dump, we can see that. Now we just step over this. We can see here this has now mutated the key again. So this is now actually mixed in some additional data. So when I did this originally, I remember thinking, all right, we'll pause here because these two functions obviously mutate the input. Like we've experimentally seen that the key comes in and it passes through these two functions and it becomes different. And then it, you know, you can kind of see it from a glance here. It's going to do some sort of checking on it. You know, the local 20 output here gets assigned to this pbvar2, and then this pbvar2 is used in here. So, like, without actually going through the mechanics of reversing this, like from a high level view, it looks like you pass in your input, it does some transformations over it, and then it does some sort of checks on it. So what we're going to do now is try and figure out what those checks do, and we'll kind of bring some of that into code so we can start to replicate it. No, I'm not really working on the Iris engine anymore. I architected. So Iris is how I started doing YouTube. I was talking about the game engine that I wrote, and I kind of was over ambitious in what I wanted to achieve, and kind of architected myself into a corner. And it's actually now incredibly difficult to extend in any meaningful way. What I do want to do on livestream was the project I was talking about, is I'd like to go back to doing some C++ and some OpenGL programming. So I think it might be fun to do that over a couple of streams together. Like from scratch, we'll build our own, like, you know, we'll do the window, we'll resolve the OpenGL functions, we'll build out the shaders, we'll build out the maths classes, we'll kind of build out a camera class, we'll kind of go through the motions of making like a little something rendered in 3D, but like entirely from scratch. I think it'll be fun. So what have we got? So looking at the assembly here, you can see that, Ghidra's basically kind of told us that, this output pointer is 13 bytes on the stack, and then this output pointer is 32 bytes on the stack. I believe either Ghidra's got the sizes wrong or it's inconsequential because there is no expansion or contraction of the input key. It's always the same length. So this becomes the initial output, and then this becomes the final output. So this is the shuffled key, and then this is the mixed key. Again, once you start putting names to these things, they start suddenly becoming a lot easier to read. So this is the mixed key pointer, I guess, or you could call it a cursor. And now that I've given this a name, the code suddenly starts becoming a little bit more readable. Yeah, so I think basic C++ OpenGL, I'll do it on stream, and then I'll just package those up into videos, so they'll kind of be like easier to produce videos for people and hopefully useful. Right, okay, so let's look at this first function. So this, I'm going to call this shuffle key, which actually is now very close to shuffled key, but what are you going to do? So this in the first glance looks complex, and I mean it's all complex trying to figure this out, but you can kind of break it down and start working through it step by step, and actually it turns out to not be too bad. So this here is kind of strange, right? So we've got this is the out str, and this is the in str, and I think we can retype this as well. So you can change the types in Ghidra to maybe make things a little bit more useful, because Ghidra can only kind of heuristically guess at what the types are, and on 32-bit, an int is the same size as a pointer, so it's kind of gets it a little bit confused sometimes. Like, it's successfully worked out that this is a char star, but it thinks it's an int, whereas we know from the previous code that it's a char star, and also from looking at it in the debugger. So somewhere in here there's retype variable. Let's make this char star. Sure. Okay, and that just, changes. Now that you've given Ghidra a little bit more context, it kind of improves how it may be able to disassemble the code a bit, potentially. Also, I think it just makes it easier to kind of visualize and understand what's going on. Excuse me. So this code here is a little bit strange. It's taking the current value of instra, so it's dereferencing. So this is a char array, which is a char pointer, right? Which effectively means it's a char array. So cvar here gets the first byte, and then assigns it back into some offset into instra, which I think is very strange to look at. You're basically saying, give me the first byte of this array, and then stuff it back in somewhere else in here, and then it advances it by 1, and then it keeps going to this as null. So this, if you ignore this line here, these 1, 2, 3, 4 lines are iterating through the string byte by byte. That's just, that's just what it's doing, and you can kind of, you can kind of work through that line by line. This, I think, is very strange until you work out what ivar2 is, and it's the difference between the instra and the outstra. So what it's basically saying is, give me the address of both of these arrays and find me basically the distance between them, and then use that distance as an offset into the instra, which will be the start of outstra. I think if I remember doing this correctly, it effectively passes a massive negative number in here, which in assembly, it's fine, that's just what it does. But it just looks very strange that you're kind of assigning, it looks like you're assigning the string back to itself, but actually the offset you've got is massive, well, relatively massive, and actually points to the outstring. So all this is doing, this here is just a str copy. I think I might have said memcopy in the in the video. I mean, arguably the same thing, but it does loop till it gets a null byte. So this is just copying instra to outstra. So that's all we've really achieved by these few lines. We could probably heuristically see that as well, if, I guess for anyone who doesn't believe me. Next. And then where are we? I've lost the, where am I paused? A7F. Have I gone too far? Where is this? This is the point. It's quite easy to get lost between the two. Okay, fine. So I want to F9. Okay, fine. There we go. And then we get F7 will step into the function. So this will effectively do one step into the function rather than over it. And then we just look for that assembly here, which was in here, wherever this test and jump is. So let's take the output of the first function and we'll just step through and we should find that at the end of here. Yeah, you can see here it's copying into this outstra byte by byte our string. So why write strcpy like this to make it cryptic, or was it obfuscated by an algorithm? It's impossible to say. I strongly suspect this is was maybe just a hand-rolled loop in the original code, and this is just like with the state of compilers back then, it probably wasn't optimized away very well. So I strongly suspect this was someone literally just hand-rolling their own loop. That's my guess, but like I've got no real evidence to back that other than just like there's no reason it shouldn't have just called strcpy. But hey, you know, this is what it is. I don't think any of this code is hand-rolled assembly, but again, it's impossible to say. It just doesn't, you know, doesn't feel like it. Anyway, so that's what we can do here is, because I don't really want to sit through this loop every time, so we can just find the instruction after the one, you know, we'll execute when it's done, when the loop is done, and then just press F9. So now we're done, and this is all copied in here. So now we can start looking at what's going on next. So it takes so dat here is some global data, and it uses that as an array index into the outstra, stores that. So this basically says get this, so get the second digit in this case. This is just some global data. And then take the oxd element, store that into here, and then put cv1 put your stored value over the oxd. So what this effectively does is swap. This is a swap, right? This is just it's taking this character, the character of this address, storing it in a temporary, overwriting a new one at this index into here, and then taking this one that you copied, your temporary one, and storing it over this. So all it's really doing is just swapping a bunch of characters. What I found is actually kind of renaming these helps a little bit. So if you just like do, I don't know, G2, now I can see that I'm swapping the second and the oxd element, and then you can kind of go through all these 4, 5, whatever. I'm not going to do them all now because I've already been talking for nearly an hour and I'm like nowhere near where I thought we'd be a little bit further through, which is fine. So what I did was I took that and I copied that into C++ code here. So you can see I've redone the shuffle key here, you know, 2 and D, and I just use memcopy rather than hand rolling it. But this recreates that. It sticks null byte on the end. So that's all this does is literally just take some hard coded offsets and just swaps the bytes around. Okay, so it's not too bad, right? We're swapping some bytes around. After that comes the next function, which is the mix key, and this is a little bit more complicated. This does a little bit more. because it also has more function calls in it, which means we kind of have to go a bit further. So what I'm going to do is going to continue over. So if you do Control F9, that runs you to the next return, which effectively means you've like this equivalent of fin in GDB, like you finished the function. Step over, step over, step over, step over, and now we're going to step into the new function where we've got some output data again, and then our shuffle key. So I'll step into this. I will step down to the first function. So the first function is passed our shuffled string and the constant d, which we can see here. Okay, nothing too surprising. This effectively produces like a hash or a checksum. You know, you can see here that it's going through the characters one by one because it's ivar2 plus param1. So this is the instra, and this was the oxd whatever constant. I think it's probably the length. Yeah. So it basically produces over this number of characters this kind of continuing sum of percentage of modulo operators and summing them up. So this really just produces a checksum. In fact, I think we can kind of see this here. If I just step over this, then we can see here that this is the value it's produced. This this EAX value. So again, like this is like create checksum, and then uvar3 here. So this will be, we can call this checksum, and then again this will start filling in bits of information, start helping us make a bit more sense of things. So then we get to the next function, which takes in a stack address, and then our checksum XORed with this third parameter that's passed. I think when I first did this, I called this like magic because I didn't really know what it was, but it's got a fixed value. It is it's OX1C830 or something like that. I can't remember the exact number, but this here is the same every time we run it. We can go back and look at that in the debugger in a minute, but all you have to really know is that like the flow is you take the key, you create your checksum, you XOR it with some fixed constant that is just always passed into this function, and then pass that into this function. Now again, and key checksum. I recreated the checksum function here again, just kind of looking at the assembly, looking at the decompilation, and just typing it out. And again, what I could do, because I print out all these as I go along, I could run that through the code and check it, matched whatever input I gave it matched the output. There's no need to kind of go through that. I hope you can kind of believe me that this does indeed do the checksum things. The next function is kind of, again, it's a bit of a strange one. You have to stare at it a little bit, but it takes your param2, which is your checksum XORed with your magic. So this is some sort of checksum-ish thing, and then splits it into 5-bit chunks, and then uses those as indices into this global array here. So what it's doing is taking that number, splitting it into 5-bit chunks, and using each of those as an index. Hopefully that you can kind of see that. You have to stare at it a little bit, but eventually this thing kind of starts pulling itself out. I'm signing into these params here, 2, 3, 4, 5, and 6. And then I am using those to actually then set params 1, 2, 3, 4, 5, 6, and 7 as indices into this array. So this is a big global block of data. Sorry, I realised I've kind of gotten a bit lost in this and missed some of the chat messages. Yes, that's correct. This is why it's a bad idea to put the same text in all the boxes. You do miss the swaps. That's very much the case. So apologies if I missed out on your messages there. Okay, so this I believe is partly where those, or entirely, I can't remember, where those extra characters get mixed in. I'm still at the first. We haven't even gotten to the game yet. This is solving this just allows us to get to the game, or install it. So by using these as indices into this array, and these are all ASCII characters, right? 6, 4, 3, 8, 2, some of the best. This is where those extra characters get mixed in, but notice like it only puts them into certain places as well, so it's not mixing in like loads and loads of characters. In fact, I think you can see this. Let's take a dump of this later on. Control F9. It only actually affects some of the characters. So remember we've got like 4 A's, 4 B's, 4 C's, 4 D's, 4 E's. All the C's remain unchanged. This A remains unchanged. In fact, is this even the end of it? I think it might shuffle some of these back. But basically, it doesn't actually affect all the characters. It turns out I think there's only 7 characters here that are actually part of this whole algorithm, and the rest can change kind of randomly. Well, not randomly, like, you know, it doesn't matter what the value of them is. So then we return from this. So this is storing into. So these 8 bytes here become the result of that lookup. So this is doing some sort of table lookup, and these become the sort of looked up chars. Not great names. Looked up chats. Looked up chars. And then I'm trying to remember what happens next. So I think I've recreated that in the code. So this creates the checksum. Yeah, again, I've split up and I've got this array here, kind of hard code. I just pulled that out of the binary. So what happens next? So this, I believe, is then inserting those looked up characters into that array. I think this is what then substitutes them in, because the next interesting thing is this function here, which performs another transformation. It does another lookup into another table. So you've got 2 kind of global lookup tables. Again, this splits it up into not even 5-bit chunks, sort of random bit chunks, and again uses those as array indexes into this global data and pulls those out. So check out transformation there. And what's the transform magic? What was that? I think that's... Oh yeah, it actually then mutates your checksum again. Before you get to the end of the function, it does this kind of like rolling XOR across some more data. Yeah, I've recreated it here. So what does it do? It takes your magic, which is that fixed constant of x1, c7, whatever it is that's passed in, and then it XORs that with your key. Well, actually, sorry, it uses your local key XORed with the magic as an index into some other global data, and then XORs that in with the magic shifted by 8. So I don't remember, to be honest, I'll be honest with you, I didn't fully kind of go through the mechanics of understanding this. I took this code and compiled it and then fixed it up. And you know, sometimes that's kind of enough you need. I don't actually particularly care what this is doing. I just need to care that semantically it's changing this magic because it then passes it into this function here. That's it, I remember now. And I needed to know how it was transformed so I could compute this final step, because this here in my code, I call it checksum transform. Here you go. And I needed to know this transform magic. So that's what this last function does. And then I think basically what it does is it kind of goes through all this chuff, and at the end of it, it shuffles the key again. So remember, shuffle key is swaps between fixed like known points. So this effectively undoes the original shuffle. So this moves some you originally move some keys around, some characters around, you mutate them, and then you move them all back. So hopefully that kind of makes sense. It's been a while since I must admit, I kind of, as soon as the video is done, sort of take a deep breath, relax, and only have a couple of beers, and then the memory of all this slowly starts to fade, which is why I like doing it again on live stream, because it forces me to try and remember what I did and I guess defend my position a little bit. Is a brute force attack on the key an option? No, there's too many combinations. I think if you fully reverse this and then you realise that actually only 7 of the characters are related to the checksum, then yes, you could brute force those 7. But at that point, you've kind of reversed it all, so you would just go and figure out the keys yourself. No, I don't do reverse engineering as part of my day job. It's kind of this is a hobby. This is something fun. Many years ago, I used to work in cybersecurity, but I don't anymore. So this is kind of a way of me just kind of keeping those skills sharp. So yeah, so you do the shuffle, you move them back, and the reason you move them back is because after the, where is it? Here we go. So this is the final bit here. So if you stare at this hard enough, you can probably figure out how shuffle key and mix key works. That's that's kind of what we've done. I said we're going a little bit more in depth. I may have glossed over one or two things, but by and large, you can kind of take the code out and figure out how it works. I kind of go through more deeply into my thought process as well. This is a partially unrolled loop. So loop unrolling is an optimization where for compiler can see that the loop does a certain operation over a fixed number of iterations, say 8. It could just inline that assembly 8 times, so there is no loop, which means there's no jump, which means kind of potentially more optimal in terms of, I don't know, instruction caching, or at least not having to perform those jumps. You can also do like a partial unroll. So this is basically said I'm gonna execute this operation on two characters at a time, so there's only half the number of loop iterations effectively. Because what it does is it takes the mix key pointer, it dereferences the first character or the current character at the front, and then it checks if it is not equal to the start of the string. So what it's basically doing is it's saying, where am I? Oh, sorry, this is param1, the input. So it's basically what this is doing is it's checking each character after you've done these 2 transformations and stored the mix key pointer. Is it now equal to the original pointer you passed in? You can see here that for the second partially unrolled loop, it takes index 1 and index 1, and then it actually increments this by 2. So this is going to go through. It's going to go through your input string 2 characters at a time and check each pair of 2 is equal to the corresponding 2 in the post mixed function. Does 2 iterations at a time. Yes, you can think of it as doing 2 iterations at a time. Again, it's just one of those things where it just looks a bit strange when you see it until you kind of dig deep and kind of figure it out. I could just be making up every word. I could just be making every word of this up and explaining like it's fact, and you would go along with it. That is, yes, maybe I am. Like, no one's called me out yet. So maybe I've had ChatGPT write me a very convincing sounding script on this, and I've just delivering it with confidence. But basically, all this is doing is just checking that is the input you've given the same as after it's gone through these 2 functions, which is why it does that undo shuffle at the end. So it's going to move some stuff around, mutate it, and mute it back. And the aim of the game is, can you come up with some input that basically means after it goes through those transformations, it remains the same. And it turns out you can, because that's what I did. This will, if you run this code, it will print out a valid key for you. And then the game ends and runs and off it goes. So I'm going to take a brief pause. Well, not pause, but that's like a whirlwind tour of the key gen. Hopefully it's kind of useful for people to kind of see the mental processes that I went through. I don't time it, but I've gone through in an hour what probably took me a week. So again, I might have sped through a few bits, but hopefully you can kind of just see like the process. The main thing for me to convey is like the process of solving these kind of problems. You find an the message box, you put a breakpoint on it, you work your way back, and then you just sort of basically slowly start chipping away at the problem. do I think ARM changes much for reverse engineering? Like, no, it's just reverse engineering is reverse engineering. I think ARM is easier to read. I think, you know, the reduced instruction set means there's kind of less code, I guess. But it's got some interesting things like, was it the barrel shifter and stuff, and the post increment, pre increment instructions. So, you know, ARM's got some interesting stuff. And I would be pretty bad at reverse engineering ARM now because it's been many years since I've looked at it. I'm not. But yeah, I think about an hour in. I will stream for a little bit longer because I think it might be fun to try and go through some of the anti-debugging techniques and how I figured those out. I don't think we'll get to the point where we can kind of deobfuscate the packed DLL and repackage it up, but if you're desperate to know more about that, you could just go and watch the video again. Let's see if I can get us to a point where let's see if I can find a binary, and by find a binary you'll see what I mean in a second. So inside the Sims2 install file is the binary, and this is just a mere subset of the ones that I was testing out with. Unfortunately, neither test 2, test 3, test 4, patched again, patch, DLL or DLL patched quite did what I want them to do, but they are sure all there for prosperity's sake. And I think in my VM I have final 1 through 5, of which none of them were the final one, and I think there might have even been a like, this is it and this was not it. But here we go. So I believe the original is Sims2exe, so I'm going to try and open that up in the debugger. In fact, I might even have it under recent. Okay, we're back. I bet I have. I am going to delete all my breakpoints. So breakpoints will show you all the breakpoints you've got, whether they are in loaded modules or not. It'll kind of be there. Like if you set them in a DLL that's not been loaded yet, they'll be there. They'll be waiting for you. So I've just removed all those because I want to kind of. I have no idea what I've got set, because if I just continue, then this is what we get. So a debugger has been detected. Unload the debugger and try again. So this is a classic kind of game's not wanting you to do exactly what I'm doing. So they'll try and attempt to detect at runtime the presence of a debugger, and if they detect it, then they will exit out or end the program for you. So how do you generate the key that transforms to itself? I basically just worked the algorithm backwards to try and work out what each one was doing, and then just kind of put the pieces back, literally reversed it, put it in backwards order until I found an input that satisfied those constraints. Very interested in learning more about the anti-debugging, still kind of struggling with dynamic analysis because I'm struggling to find the anti-debugging checks to patch. Yeah, I think this is one of those things where it does require a little bit of guilty knowledge, as in like you kind of need to know how someone's going to do anti-debugging in order to patch it out. I think going in with like zero knowledge, you will struggle. Why do I not use Cilia Hide? So that Cilia Hide? I don't know how to pronounce it. So there is a plugin for x64 debug. I believe I even have it installed called Cilia Hide, and this will attempt. So if you want to know a list of all the potential anti-debugging techniques, here they all are, and this plugin will actually go through and attempt to patch them out for you. I don't always find this works, and like a lot of things in life, I find it more easy. I find it a lot of fun to kind of go through and figure it out for myself. I must admit, the Sims 2 one is not too egregious, so it's kind of fun to kind of figure out yourself. And again, I think it makes for more hopefully interesting and engaging content if you, I'm not saying I wouldn't, I would use pre-made tools where it makes sense, but I think for a video, if I just said, I use this plugin and I disabled anti-debugging, I don't think that's as kind of potentially engaging as if I actually did the hard graph myself. So that's kind of my thoughts on it. So again, what we could do is put a breakpoint on the message box and work our way out, but I kind of got a little bit lucky with this because went to symbols, and then I went to kernel 32, and I picked the most basic check, which is debugger present? Right, so let me get the docs up. This is a Win32 first class Win32 function. Determines whether the calling process is being debugged by a user mode debugger. Like literally, Windows will tell you if the process is being run by a debugger. Is being run under a debugger. So I was like, I'm just going to set a breakpoint on this and see what happens. And if I press, nope, not press that, press F9, then it's hit. So the first thing they do, or sorry, the first thing I come across is them using the most basic check. Now this is interesting because I think if they hadn't used this, it would have made my life slightly harder, because this was my into finding where all the anti-debug missions were, and it turns out they're all kind of co-located together. So I find it kind of ironic that by using the most basic one that is very easy to bypass, it actually made my life a little bit easier. But hey ho, hindsight. I guess these things are all obvious in hindsight. So I was reversing a childhood game of mine, and my x82 debug was suddenly only single stepping and showing an exception single step, zero relevant Google results. Still haven't figured it out. Hard to debug. Yeah, debugging the debugger is actually kind of a pain. I've had something similar to before, and I just blew away all the x64 debug files. There's a folder. Let me show you. I don't know if this will help you, and there is a caveat to it, but. So if you go to wherever you've got your x64 debug release, for instance, I'm doing x32, if you blow away the database, it kind of, I don't know if it catches something strange, but I have found that some errors I've had in x64 debug have been fixed by just deleting this, or in my case, because I refuse to delete anything, calling it back and back 2 and back 3. So as you can see, I've done this several times. It will remove all your breakpoints, just FYI. So just before you go and delete all that, and then all your sort of heart and comments and it's the database that banks all the saved data for that file for your debugging session. So by removing that, you will lose all your state. It'll be as if you'd opened it up for the first time. But I have found before that has fixed some issues in the debugger for me. So yeah. So this is the sort of jump point into the kernel. This is just how a lot of the kernel 32 is kind of laid out. So caps lock on, that's going to absolutely ruin my day. If we follow the jump, then I'm not too worried about the implementation of it. It's getting something from the PEB or whatever. Well, in fact, it is getting something from the PEB, but here it returns 1. So it's saying I am under a debugger. So you can double click this, and you can literally just change that to 0. Be like, no, you're not being debugged. I will use the debugger to tell you that you're not being debugged, which I think is interesting. And then if you continue this, then eventually unload the debugger and try again. So this is the kind of the hint to you that there is more than one anti-debugging technique, and they have not just used the most simple one out there. Spore video when? Oh, I mean that's couldn't possibly comment on future videos. So made a memory hack to get the user more coins in their account. Only issues with Windows 8 onwards. The hack stopped due to random memory addresses. Yes, so you've come across ASLR, address space layout randomization, where so this 32-bit binary is always loaded at the same address every time, but on modern builds of modern software, the operating system will load it into a random address, which makes things a little bit more tricky. Yeah. I think I might, before I don't know, I've got an idea for a few videos next. Maybe they're not quite as intense as this, just because this takes like 100 hours is a long time. I might try something, maybe something simpler next. I don't know. We'll see how it goes. Yeah, I heard Spore is pretty gnarly. Again, it might be one of those things where I sort of spend a month on it and then I just kind of produce a video on what I found, or we'll see. Okay, so what we'll do is we'll go back around. We'll play this game again. We'll go back around, and then we can look at the call stack. We can see here that it's been called from this function. which is then called from. What am I doing? What am I doing? I lost myself. This function here. So I've lost the bit I wanted to get to, which is a little bit annoying. Where was I? Where's the... Let's just continue. Do I debug on console? Please do Dreamcast. Shenmue maybe. So that's kind of interesting because I have an original Dreamcast somewhere with Shenmue, and Shenmue is one of my all-time favorite games, especially on the Dreamcast. I love the Dreamcast. I've never really considered debugging consoles because I'm not really I'm not a hardware person, and I know there's kind of, you have to find debug ports and stuff like that, and maybe solder something. I don't really know. It's not at all my area of expertise, so it might be fun to do, but I would probably maybe start off with something simple and work my way up. You finally switched to NeoVim in your WSL. Would it ever interest you to give out some of the most used NeoVim plugins configs? So all I really do is just use Kickstart. Where is this? Oh, steady. I just use this, which is a kind of pre-built starting point for NeoVim. Contains a load of common plugins that you would want, and then it's got LSPs kind of set up ready to go. You just uncomment them and it installs them. That's really all I use, and I might have installed one or two other plugins, but really I just use that and then set up with a theme. Yeah, I do have an email for contact. It's on the YouTube. It's on my YouTube channel page under the About Me section. So we'll continue over this, and okay. Here we are, cool EX. Where am I at? So you can see here. So I remember now this has got some weird messed up call stack, which kind of makes the tooling slightly harder to use. That's fine. We can just kind of do this in assembly. So call EAX here. It's loaded that function up into EAX. It doesn't call it directly, which is why it's kind of harder to find in the code. But after it calls this, it moves EAX into the SI register, then it does test SI, and then it jumps if that is equal out. So this is basically... is this one I've already patched? No, never mind. And then it basically jumps out. So this is just checking whether the return result is 0 or 1. So if I change this to 0, as in there is no debugger attached, it will continue, and then it'll move down here, and then it'll write out. And then we end up here. This is where I wanted to get to. So this here is a whole bunch of functions that it calls, and then it checks the return value of each one. And if the return value is 0, then if the return value is not 0, then it jumps to the end. And if you follow this through, eventually this ends up. The result of this function, I believe, will trigger that message box. So all these functions are doing some form of verification, and the game is to kind of figure out what all those do. And I'll kind of go through some of those now. Yeah, I'm sure there's an active homebrew community for Dreamcast, and that's probably one of the things where I did look at prior art just to kind of get myself bootstrapped. I don't think I would ever consider myself smart enough to figure out all those, any of that stuff from scratch, because that is some hard graft figuring that out. So a couple of things here. You could just jump over this to fix these. I kind of didn't know that ahead of time. I didn't know what these functions were doing, and then I kind of ended up looking at how all the reverse engineering, the anti-debugging techniques worked, and then I ended up, what I actually ended up doing at the end was patching this instruction ret, because there's some nops here, to XOR EAX and then ret, which effectively nullifies all the checks inside and always returns success. because 0 is success in this case. So if we keep stepping, what I'm going to set a breakpoint here so we can come back to here later. So the next one just returns 0. I didn't even look at that function. I was just like, that returns 0. I don't care about it. We're all good. Next function returns 0. Didn't even look at that. Don't care about it. Next function returns 1, which means it will jump to the end. So we know that this function here is another thing that is returning 1 when it should return 0. So this is probably an anti-debugging check. So we're going to restart F9, keep going. So we end up with, so I'll take this breakpoint off. Oh no, I need to leave this one on because I've got to patch it every time. Hang on, let me start again. I remember how I did this now. I'll get here. I set a breakpoint after here on the test. So go here, turn that off, get here, change it. I don't know where this like 19 comes from, but from my experimentation, I can just set it to 0 and it's fine. Yes, this is a keygen from 20 years ago. This program here is x64 debug. It's a Win32 debugger, and behind it I have Ghidra, the open source decompiler disassembler. So we've set that to 0. So now we can step over to this, and then we can step inside, and we can start looking at what this does. So this does, what does it do? Calls get version A, which I don't think we care about. Jumps past that ret. I might have to go and actually open this up in Ghidra to remind myself what this does. What's wrong with this? That's it. It has this function here. I believe the result of it, that's it. It deobfuscates function. So the idea is this function doesn't want you to know it's calling anti-query information process. So internally this function, this is passed some sort of ID, and then this function internally deobfuscates that into this. So then presumably somewhere it's going to call a register. I guess that's it here. Let's see if that's right. Call it process. So call EDI. EDI is anti-query information process. So anti-query information process is an internal Windows function. You are highly recommended to not call this. It may be altered or unavailable in future versions of Windows. It is available in every version of Windows that I'm aware of. Applications should use the alternate functions listed on this topic. Windows, I think this is Windows kind of like weasel words because they don't like breaking backwards compatibility. So this is like, oh, we might break backwards compatibility on this function. And as far as I'm aware, they haven't. But I'm not an expert on the history of the Windows API. At least every time I've called it, it's certainly been there. So you give it handles and process, and then you get back this process. You know, it's a Windows function, so it's super angry in uppercase and shouting at you. It gives you back a process information class. Sorry, you give it a process information class, and you get back out of it a process information. The information class is kind of one of those functions where you give it an ID, and then depending on the ID, depends on what data it writes out to you. So these are all the things that you can give it, and I believe when we go to call it, we give it a 7, and a 7 is a process debug port. So this retrieves a pointer to a port number of the debugger of the process. So if you get a non-zero value, it indicates that the process is being run under a debugger. So again, this is just another way of querying the Windows API to see if a debugger is being run. And that's what it does. I don't think I actually grabbed the pointer there, but it definitely comes back as a non-zero value. So if we run to the end of this, step out of here, we can see here that we got 1. So what we do is, again, step that there, set that to 0, and then we can continue on our merry way. So this call here also fails, so now I get the joy of restarting all this. 9. Oh, shoot! Forgot to unpatch that value. And then step into this. And go through get version 8. I think this does the similar deobfuscation thing. I think. No, this is interesting. So this fs:18 is a instruction assembly to get the PEB, the process execution block. So the process execution block is a Win32 construct. The kernel creates one of these and maintains one of these for every running process. And it's just it's an internal structure. This structure may be altered in future versions of Windows. Contains process information. So look, it's got all this stuff in here, and this is just the stuff that Windows admits to. Like, they don't admit to whatever this reserved 2 bytes are, or what this reserved 6 is. Reverse engineers have figured out, I believe, a lot of these, and if you look at like ReactOS or something like that, it's got a lot of the information in, or Windows internals, but these are the ones they kind of admit to. But if you see like mov debug pointer fs:18, then that's getting the PEB. I believe in 64-bit it is the GS segment register. These are segment registers. Windows just basically says, I will stuff the pointer to the PEB here. It doesn't, it's kind of just a Windows construct. I think it's GS in 64-bit. So yeah, that gives us access, that gives us a pointer to the PEB. So if I over this, EAX should follow this in the dump. Should be the PEB, and then being debugged is the 3rd byte, which is 19, so it's not 0. I don't know if this actually has any semantic information. It just indicates whether the specified process is currently being debugged. The PEB structure, however, is an internal operating system structure whose layout may change in the future. It is best to use the check remote debugger present function, which again is another one of these built-in Windows ones. But Sims doesn't want to do that, or EA doesn't want to do that. They're going to read the raw PEB, and they're going to be like, yep. Here you go. OX30, why are they taking OX30? Anyway, this is effectively what they do, is they check the being debugged part of the PEB. And then again, it's another way of checking if a debug's attached. So this will be 1. So what we'll do is we'll step here, stack a breakpoint, make this 0. And then we'll keep going. And I believe there is 1 more. So this again returns 0. So I don't care about it. This one returns 0. So I don't care about it. And this one returns 0. So I don't care about it. And this one, returns 0. I missed one. I'm sure there was one more. Oh, okay, fine. There is another one, but I need to arm it. I need to set off the trap that it has laid for me, because it is a very funny trap. Let's try this again. Right, so 9, F9, let's go with that, that's fine. Right, so 0, and then 0, and then 0. Okay, fine. Now I'll step through again. 0, so I don't care about that. 1, so I do care about this one. I care very much about this one, because this one does something interesting. So I guess, oh, what am I doing? Where's my other huge window? Here we go. Right. So it's actually, this is might be easier to read because this has already got some comments in it from when I last did this. Basically, this function, this sort of last remaining anti-debugging function, does some chuff. Get version A again. I don't really care about this. I'm not interested. But what it does do is this is some global data. So this is a static pointer, effectively 4 bytes. If it's 0 and this data is 0, then it calls this function, which gets the module handle. Again, it uses this string deobfuscator function that I found. I tried to strip this out of the video because it didn't really make any. It didn't really add much to the story, I felt. But anyway, through some deobfuscation techniques, it gets a handle to the loaded kernel 32 module. Kernel 32 is loaded into basically every process of Windows. I think after anti-DLL, I think it's the second library that gets loaded. And so this gets a handle to it. So this is kind of guaranteed to exist. And then what it does is it goes through it calculates some offset into the kernel 32 module, again, which is an address of where the DLL is loaded into memory. And it kind of goes through all these, some offset, but it kind of goes through all these byte by byte. So you can see here, it's got the module, and then this pi var 3 is some offset plus aux1c, and then it adds 1 to this each time. And then it loops until, I don't know, this value is not 0. So really, it's kind of looping through the loaded kernel 32 module byte by byte between some 2 offsets, between a start and end. Don't really care what the start and end is. It is looking to see if any of those bytes are OXCC. Now, OXCC is a very interesting byte. It's one of my top 2 favorite x86 instructions. It's definitely one of my top favorite 2 1-byte x86 instructions, because OXCC is the instruction for a breakpoint. So I don't know if you've ever really sort of considered how a debugger actually works and how it actually sets breakpoints, but it must your debugger, when I set a breakpoint, right? Like this means like when the other process is running, it has to when this bit of code is executed, it has to somehow stop, and Windows has to somehow tell the debugger, me, that it has stopped, so I can then get the registers and interact and step it over and interact with it. I don't know if you've ever kind of thought about how this might work under the hood, but the way it works is the debugger silently inserts a 1-byte instruction here called OXCC, with the value OXCC, and that when x86 executes that, it will say, oh, I've hit a breakpoint instruction. It will then switch context to the kernel, and it'll say a breakpoint has been hit in this process, and then the kernel will go through its processes. It'll find the one that's been hit, and then it will say, oh, is there a debugger attached to it? Okay, I will now suspend that process, and I will notify the debugger that a breakpoint has been hit. But basically, so every time I click this, right, every time I press F2, X32 debug is stamping in OXCC into this address, but because it does it all silently for you, it doesn't show up in the disassembly. It's all kind of transparent to you, and then when you resume the code, it swaps it back out, so it actually executes the real code. So what this is doing, which I think is really clever, when I figured this out, I was like, okay, it's quite cute. It's going through kernel 32 to see if you set any breakpoints there. In fact, because we can actually see this, I'll actually set a breakpoint here when it does the comp. Here, let's see if I have to reload the whole thing, which is annoying. Do the stance again. And okay, fine. So it's comparing this, calculating the address based on the addition of EBX and the AX, and saying is that equal to OXCC, and then at some point when it's true, it will hit here. So what I'll do is if I just jump to here, okay. So this is hit. So this was returned true. So if I do, calculate. Pro tip: always have a calculator handy. What did I say? EX plus EBX. If I take this and I go to that address, then it's it's where we set the debugger earlier is debugger present. This is the breakpoint I set. So it's literally gone through the program's memory and gone to look to see if I've actually set any debug breakpoints. So the very act of debugging this code and setting a breakpoint here has caused it to fail another check, which I don't know. I think is quite funny. So yeah, but the fix to all this, because for better or worse, they put all the debug checks on one function, right? And they all basically boil down to whether this whole function returns 1 or 0. It doesn't matter how many anti-debugging checks it's got in here, right? It's just going to return 0 if it didn't if it's all like okay. So what you can do is hang on, hold on. Choppy, that's it. Nope. Space, that's right. So all you can basically do is you can just patch this out to be right at the end, like XOR EAX right, and then ret, and then it doesn't matter what it does in that function. Then it'll always return 0 at the end. Yeah, or you could have just jumped straight to the, or you could have just after the function epilogue, you could have just jumped straight to the prologue. It doesn't really matter. The reason I did it this way is because I don't actually know what all these other functions are doing. That they return 0, but that doesn't mean they're not setting up some internal state or loading something. So I wanted it to kind of go through the motions of calling all those functions because I didn't want to have to actually check if they did anything, if they had any side effects, and get to the end and be like, it's all okay. Of course. Actually patching this in the binary is a massive pain because this code here, where am I acting? This DLL, right, doesn't exist until the program runs. It unpacks itself from the main executable and it's obfuscated in there. So you have to reverse the obfuscation. Well, basically you have to dump this DLL, make the patch, find out the obfuscation method, reverse it, so you effectively reverse obfuscate this so it's back to what the game is thinking it should be, stuff it back into the executable, and then when the executable runs, it will find your patch code, deobfuscate it, which you know will work because you obfuscated it, and then write it to file and load it normally. Anyway, that's the way I did it. And then, yeah, that's kind of how it works. Again, like putting a ret at the top of the function, the first thing it did was execute, assuming your stack is correct and there's no function epilogue or prologue you need or anything like that, then it still has the same problem that I was trying to avoid, is that function calls a whole bunch of other functions and I don't know what they all do and they might have important side effects. So for me, like conceptually, I wanted it to just run through all the code, execute all those functions, and then just at the end be like, yeah, everything's cool, because that way I kind of get the best of both worlds. Also, I think it makes more interesting content to kind of actually dig through all those and figure out what they do. But, and it was a fun journey as well. Like, I really enjoyed digging through all those codes, because they're pretty basic anti-debugging techniques as far as things go. So it was kind of fun just to dig through those. Anyway, that's all I've really got planned for today. I'll obviously hang around for a few more minutes if anyone's got any questions or want to chat about anything. I am currently streaming on Twitch, like right here, right now. I believe it's a pinned comment in the chat. If you prefer Twitch, no, you can't patch it in unobfuscated because the game runs as it unpacks the DLL. It runs through an obfuscation algorithm, so it will every single one of these bytes gets transformed in some way. So you have to be able to set it up so that when that transformation is done, you end up with the end result, which is the patch DLL. Yeah, I mean, I don't know. Some people prefer Twitch, some prefer YouTube. The technology is there to stream to both, so it doesn't really worry me. Like I said, I would be kind of fun to maybe try and get into the Twitch affiliate program, but I do need to stream a little bit more. Oh, if you are on YouTube though, that has reminded me, I have a gift. I'm allowed to gift channel membership. I would, but my tabs died. Okay, here you go. Give 5 now. So 5 people were randomly given 1 month's membership, which is exciting. It means you get early access to videos, a few behind the scenes posts, etc., etc. So that's it. Thank you very much. Do come along. Chat. Behind the scenes. I've not started doing like any like members only streams or videos yet. It's more just like the community side of it. So early access to videos, behind the scenes posts, you know, I'll probably talk about like the videos I'm doing them as I'm doing them, stuff like that. I think you get some emotes as well, which is exciting. But anyway, I hope everyone enjoyed that. I imagine people will be jumping off on to do something new soon. In fact, when I stream went, oh man, I really not regret saying that, because I really said I would do it. I do want to do. I really want to try streaming some games at some point. Just find the time. I want to try streaming a bit more with like a technical project, and then maybe sort of intersperse some games into that. I think that's my current plan. Early access stuff is just I don't have a Patreon. I do have YouTube membership. I figured it's easy just to commit to one, and YouTube tends to prefer it if you don't navigate people away from its platform. Although I do that with Twitch now, so what are you going to do? But yeah, there's just one tier, nice and simple, YouTube membership, nice and easy. If you're interested, obviously there's absolutely no obligation to. Well, I get to do 10 giveaways a month, so we should roll the dice next time. So this comes up a lot. Like, I think about this a lot. Are you interested in making more educational content? Like, there's a lot of really good educational content out there already, I think, especially around like programming and C++. So I think it means more like tutorial stuff. I think about it. It's not really like, I'm trying to think of the best way of explaining it. Like, I don't think you'll get like massive growth on YouTube by doing tutorial content, and that doesn't mean there's not a place for it, and it doesn't mean people shouldn't do it. I just think for me, like the sort of big videos that take up all my time tend to generate quite a lot of new viewers and bring in a lot more new people, and that's kind of where I'm focused at the moment. If you're anywhere in the YouTube kind of meta, there's kind of the concept of browse-based content and search-based content, and search-based content, which is tutorials, tends to be a bit more of a slow burner, because people come along, they get the information they need, and then they leave, and then that kind of you try and rank on search, and that kind of builds up. But for browse-based content, which is what is sort of suggested to you on the front page and on the upcoming next, that's where you kind of tend to see bigger, faster growth, and that's really what I'm kind of focused in on at the moment. But yeah, hopefully this is kind of educational, but not necessarily like tutorial based. But I do think about it. I think it's very hard to kind of stand out in that area, whereas at least I think in what I'm doing now, I've kind of found a bit of a niche where I can stand out. There are other people doing reverse engineering on YouTube, and they've got some really good content, but because it's quite technically challenging, it's not too oversaturated at the moment. So it's kind of a chance for me to kind of figure out what I want to do and hopefully stand out a bit. If it's using temp unpack DLL, does it keep it in memory after or read it each time it called for it? The DLL is unpacked once when the game first runs, and it reads it from its own executable file. In fact, you can see in the video it goes into it, it passes in a handle to the exe file, like the actual file on disk itself, the executable, and it seeks to a very specific position and then starts reading from it and then deobfuscates it. No, I was not part of any keygen back in the day group, unfortunately not. But someone actually was interesting. Someone, again using the email address, did reach out who was doing stuff like this back in the day and did actually do a lot of the early Sims 2 keygen stuff. We had a really good chat on email. It was great, kind of clarifying a few things that I kind of got right and a few things I definitely got wrong. Yeah, it's nice to kind of connect with people who are actually much better at it than I am. It's true, that is what a keygen back in the day group member would say. You maybe just have to take my word for it. Cool. Anyway, right, I'm going to wrap up there because I'm going to have a beer and not talk for a bit. But it was great hanging out with you guys. Thank you very much for coming along, and we'll almost certainly be doing something next weekend. So you should definitely come along. So it'll be good. It'll be fun. Catch you guys later. Thanks very much.